Math 30-2. Today we are going, I said we're going to solve these. That would be next week lessons, solving using logs. Today we are going to learn about some log rules, or what we call log laws of logarithms, right? So let's explore one of them first of all. So Johnny states that log 2 plus log 3 is log 6. Okay. Peter says that log 2 plus log 3 is log 5. Who is right? So the easiest way to double check who's right is you pull out a calculator. Okay. So let's look at Peter's first. Okay, so Peter's way of saying this is log 2 plus log 3, and then we're going to look at log 5. And we're just look at these two numbers. Okay, let's put in my calculator. So log 2, I have my calculator right here. Let's just do that. Yeah, okay. Okay, so log 2, let's hide that. Oh, let's move my face out of the way. Let's get out of this here. So log 2 bracket plus log 3 is 0.77815 ... Bunch of decimals there. And then I'm just going to go log 5. Let's see. Oh, not the same number. Close. Not the same number. So wrong. Right? So Peter's not doing it correctly here. So that's a good way. So just to prove something like this is just use a counterexample. Just show that doesn't work. Now this next one is more of a verification for this guy, for Johnny. And hopefully Johnny's correct here. So Johnny, log 2 plus log 3, which you already know is 0.77815 ... Then we're going to double check log 6. So log 6. Oh, it's the same number. 0.77815 ... It even has all the other decimals the same too. Okay. Does this pattern work for other addition statements? Okay, let's double check. So what if I want log 3 plus log 5? Okay, so log 3 plus log 5. Okay, plus log 5. Okay, so there's that number, 1 point something, 1.176. Now, if I follow the same logic, 2 and 3, how do they make 6? Multiply them together. So does that work if I go log 15? So log 15, let's see, log 15. Hey, it does work. 1.16. So that works there, okay. Now let's pick another one here and say, let's pick two other numbers that we can multiply together. So log 8 plus log 4. Okay, so is that the same as a log 32? Because 8 times 4, right? Yeah, 32. Are they the same? Well, I'm going to double check. Log 32. Awesome. Okay, 1.5. 1.505. Is that the same as log 8 plus log 4? Ah, it is exactly the same. So that works. Okay. So I think it's holding true. Select two numbers. Check to see if it works. So technically we just did that. Okay. I don't know why these are separated two boxes. So we can create a rule now. So let's say we have two numbers. Rather than putting actual numbers here, so let's say I have log A and log B. What would that be the same as in terms of up here? So up here we have like log, this is like log 3 times 5. This is log 8 times 4, because I'm adding those together. So this would be the same as a log A times B. Right, so these two would be the same. So there's a nice little rule that we can create for these two logs. Okay? You can see on the next page. So we call this rule the product law. So if I'm adding two logs, as long as they have the same base, you notice that up here we're doing log base 10 all the way through. But I just changed that base to log base 2. As long as they have the same base, if I'm adding two logs together, I just multiply what's inside those two logs. Vice versa, I could separate the two if I wanted to. Sometimes you do. You'll see later on some examples when I say evaluate. When I say evaluate, I'm not just saying plug in your calculator and give me an answer. I want you to maybe separate it, try to do this as mentally as possible using algebra and some of the laws that we know. Okay? So I can separate the two. I can combine the two. Now there's another rule, is like if I subtract the two, and the subtraction one comes from negative exponents. So I'm not going to really worry too much about the proof of this, but you could verify it the same way. Take two numbers, subtract them, or a log of a number minus a log of a number. It's the same as taking those two numbers, rather than multiplying, dividing them. Now the order is very important here. Whatever's first is divided by the second, if there's a minus sign between them. Oh, there should be a typo. There's a typo on my thing here. There should be a minus sign right there. Okay. It's a minus sign. So I can also separate the two. All right. So it's the top minus the bottom if I wanted to do that. Okay. All right. So let's use these log laws to evaluate some things here. So this first one here says, write these expressions as a single log. Okay. So as long as the bases are the same, so base 2, if there's a minus sign or a plus sign, I can apply those two laws up there. So I'm going to have here log base 2 equal 12 divided by 3. And that's log base 2 of 4. Okay? Then it says evaluate. So this is then evaluate. So I want to know what the number actually is here. So I'm going to make this equal to y. Make it equal to y, make it equal to x, whatever you want to call it. All right, I'm going to solve for y. Now you could just plug in your calculator. That's fine because we could do base numbers in your calculator. The first part is you need to understand the laws to make it into a single log. At this point, you could just plug in your calculator, but we could do this mentally and just say 2 to the power of y is equal to 4. So what to the 2 to the something is equal to 4? Oh, y is 2. So that one you could just do mentally. 2 to the power of something. So you just use your little 7 rule here, change it into log form. Right? And then we can solve for y. But you can just plug in your calculator. And it stops you from doing that. So the first one, so if you see 3 things, it's just best to go step by step. So the first 2 things, I'm going to add them together. So when you add, you multiply. So I'm going to multiply those 2 pieces together. Okay? And then the next thing I see is I'm subtracting. So what I'm going to do, you could go 7 times 8 here. 7 times 8 is 72, right? Is that right? 72? Oh, I missed my log base 6 here. Sorry, should be a little 6 there. Should be a little 6 right in there too. So I get 72, and I'm going to divide it by 2. So this would be log base 6 of 36. So I'm going to use the same logic we had before. I'm just going to make it equal to y and say, okay, what is y equal to? I know it doesn't say y up here, but we could say it's equal to y. So I've combined it into one log, so that's good. That's what I wanted to do, so that's part of my answer, right? Because it says right up here, combine it into a single logarithm. So I got that part. Then in this case, I'm going to go 6 to the power of y is equal to 36. If you know your squares times table, 6 squared is 36. So y is equal to 2. So that whole expression up there is equal to 2. Okay, so just like any order of operations, you could do your brackets first, your parentheses. So I'm going to do my parentheses here. So it's log base 5 of 6. Okay. So remember when you do this, you multiply. So I'm just going to actually write that out there for you. I'm going to put move this up here. Okay. So this is 2 times 3. So this is minus a log 6. And I'm going to go in order here. So I'm going to go log base 5 of 10 times 75, which would be log base 5 of 750. Okay, so I did my parentheses first. I did my 2 things order from left to right here. So I do my adding first, and now I'm going to do my subtracting here. So it's going to be log base 5, because they're all the same base, divided by 6. Okay. Let me just pull my calculator out because I'm just too lazy. So 125. So log base 5 of 125. And I want to know what that's equal to. Okay, so this is going to be 5 to the power of some kind of question mark. I don't know what that is yet, of 125. So you could just do the little 7 rule there. You could switch these two pieces when you change it to exponential form. 3 to the power of, or 5 to the power of 3. I'm just kind of guessing now. I know it's not 5 squared. 5 squared is 25. What's the next one up? I'm hoping it's going to be a nice number here. So this is going to end up being 3. It doesn't. Now, if it doesn't end up being a nice number, then I probably wouldn't ask this kind of question. Okay. So reading left to right, going step by step here. So the first thing I'm going to do is going to take these log base 2, 2 times 3. I'm going to leave these guys alone because there's no parentheses around them. So I'm just going to leave them first. Okay. So I get log base 2, 6 minus log base 2 of 6 minus a log base 2 of 8. I can put parentheses around things. I like parentheses. Okay, so now I'm going to divide these two because you're subtracting the 2 logs. So 6 divided by 6. I'll leave this one over here for a second. And so 6 divided by 6 is 1. And then I'm going to divide these two. This combines to log base 2 of 1 over 8. Got this little extra line there for some reason. Okay. We could do the same thing. We make this little question mark here. This is a little bit trickier question to do this way. So 2 to this little question mark is equal to 1 over 8. What's this going to end up being? So remember, 8 is the same as 1 over 8 is the same as 8 to the power of negative 1. So that's using our exponent laws. This is 2 to the power of 3. A lot of work for this one. So 2 to the negative 3 is equal to 2 to the question mark. So the question mark that we have here, this, what is this thing equal to? Let's go to negative 3. There you go. I don't know if it says verify, does it? No, it doesn't verify. So we have negative 3 in that situation. That's a bit longer, but otherwise you can just plug in your calculator at this point. It says it's just evaluate. Log base 2. So remember you have to go, I'll just pull my calculator on here. Alpha window. Go down to log base. So this is log base 2 of 1 over 8. Let's see if it's the same. Yeah, negative 3. There we go. Pretty cool. Yep, where am I? My times here. 13. Yeah, so let's do the next 2 questions here, and then we'll stop for the second part in the next video after this. Okay, so can I simplify this down? Does it end up being one of these expressions? Now, one of these expressions here, there's 1s and 2s here. Talk about that in a second, once I get this kind of simplified down first. Okay, so I'm adding. So if I add, I multiply. So this would be x times 2x. Now, of course, you can shortcut this a little bit by doing more than one step at a time. I'm not going to do that. So this would be 2x, oops, sorry, log base 2. Log base 2 of 2x squared, okay. Log base 2 of x squared, and log base 2 of y, okay. Now I'm subtracting, so I'm going to divide. I'm going to skip. So what's x squared, 2x squared divided by x squared? That just ends up being a 2. So I'll just skip that step there. Okay. Now this is where I'm trying to figure out, how does this work? What is this? So we've got this minus 2y. So I'm going to cross off a and b here. Oh, poop. Cross off a and b because they have a plus 2 log y. So I have no idea why this 2 is here. So that's kind of a weird spot. Now, what is log base 2 of 2? Log base 2 of 2. Well, this is the number. There's no x or y in it, so we're just going to plug it in my calculator. Log base 2 of 2. Now this brings up a very important property or identity of logs. So let's go alpha window, number 5, 2 of 2. We'll get 1. So that's equal to 1 minus log 2 of y. So that's going to be d in this question. Now the property that's important is that the log of a number that's the same as base. So this is log base 10. Remember, if you don't see the base there, you assume it to be 10. The log of the base number is 1. It's going to be true for all these. So if I go, so if I just make a random base here, let's say my base is -3. I don't know if that's going to actually work for us. No, it's not going to work. Maybe I should do negatives because you're not supposed to take logs and negatives. So let's pick another one here. How about 1 over 3? We could do that one. So if I put a 1 over 3 in here, yeah, I get 1. Okay, so let's do one more. Now let's put a 5 in there. Put a 5 in there. Cool. Seems to work out. So that also means if I take the natural log of e, just do the 1. Oops. Delete that. I get 1 as well. Cool. So that's a very important property. I don't know where I'm going to put that property. Let's put that property right here in a box. Might be useful for some questions in the future. Log of base b of b is always equal to 1. All right, that's super important. Okay, we'll come back to that. Okay, let's write the expression as a single log and then evaluate. So if you haven't done so, pause the video. Try these out. Okay, let's keep going. So log is going to be 15 times 14. 105. I'm subtracting these, so I'm going to go log base. Too lazy to find out what that number is right now. Let's see what we have here. Log 15. Actually, what is 14 times 15? It's 210. Okay. Oh, so this would be log 210 over 105, which is going to be log base 2 of 2 again. Oh, not 1. So, not 2. So there we go, equal to 1. Cool. That worked out for us. Let's try this one out here. So we're adding these. So it means I'm going to multiply these out. So it's going to be 2 to the 8 times 1 over 8. I'm just in my mind trying to figure out how I'm going to write that out. I'm sure there's a few other ways I can write this. Okay, let's see. So it's 2 to the 8. 2 to the power of 8. Okay, and then, so what do you say that was? 256? 256. And this is going to be times 1 over 64. So you're squaring this. You're going to square the top, you're going to square the bottom. 8 times 8 is 64. And then I'm going to go 256 divided by 64. Because that's the same as times in it by 1 over 64, right? So you could do that too. You can go 162 times 1 over 64. I don't know what I'm typing there. 64. Ends up being 4 as well. Okay. So this ends up being 4. Which is 1. Log base 4 of 4. That's a pretty cool property. Okay. Another good property to know, which I'm going to put down here, I don't think it's in my notes later on, is that log base b of 1 is always 0. You can just verify that. So like log of 1, 0. Natural log of 1. 0. Log of base 5 of 1 ends up being 0. Because you're trying to find when you make x equal to 1, well, you actually know, it'd be kind of reversing the operations. You make y is equal to 0, and then you're trying to find out what x value would make that equal to that. So it's 1. This is finding the x-intercept here. It's a very important property. Okay, so we're going to stop this video there. Sorry, it's a bit long. It's 20 minutes. And I'll see you in the next one. Bye.